we have one more speaker, and it's again my pleasure to introduce the final speaker of the day today, Dr. Isaac Mpanga. He currently works for the University of Arizona Cooperative Extension as an area associate extension agent for commercial horticulture and small acreage based in Camp Verde, Arizona. He has been serving as an extension agent for the Yavapai and Coconino counties, focusing on identifying the needs of small-scale growers in central and northern Arizona and providing science-based information to guide growers in their decision-making. Dr. Mpanga leads the effort in identifying the needs of commercial horticulture and small acreage growers through a needs assessment and implementing research and extension activities to help improve sustainable local food production, which is much needed these days, lives, communities, and economies of these farmers. Dr. Mpanga received his master's in crop sciences and his PhD in agricultural science from the University of Hohenheim in Stuttgart, Germany. And today he is going to talk about the role of extension in promoting regenerative, circular agricultural and on-farm food safety in Arizonan small farms. So it's all yours. Isaac, thank you again. And please take it over. Thank you.
Yeah, can you hear me?
Yes.
All
yes,
right.
We can hear you. Yeah, and your slides are visible too.
Great. Yeah, Dr. Ravi Shankar, thank you very much for the vivid introduction and also the Food Safety Consortium for considering me to give this presentation. I also thank the University of Arizona Cooperative Extension for their support so far since I started with this program. Yeah, so my name is Isaac Mpanga, as Dr. Ravi Shankar mentioned. I'm the Area State Extension Agent for Commercial Horticulture and Small Acreage in Yavapai and Coconino County. This is a new program that I started in December 2019, and I'm going to give you some work that I've been doing so far, and also indicate where there are red flags for food safety issues and how we are working with farmers to be able to address that. Yeah, in this picture you can see here, you can see a silvopasture system where a farmer has his orchard and raising chicken in there. And in the first place, yeah, we've heard a lot of talks from different groups, different experts about food safety and how to handle all these things. We can see that there is a red flag there if the fruits are allowed to drop on the floor before picking them. Yeah, so I'll be running you through some of the projects that I've done, extension programs, and also some research that I'm carrying out in this direction as well. Yeah, so when we talk about extension, most of us here are students, and most of us here are from industry, working with extension agents and specialists. Yeah, so just to give you a quick overview of what extension is, we have the university system. Most students are here doing very intensive research, basic research on campus. And this research is sometimes very difficult for growers and the industry members to be able to comprehend it. Yeah. So communities and industries are also having issues that need to be addressed. So extension comes as a bridge between these two entities to be able to provide linkages, in and out linkages between both the research that is readily available with facilities and also community needs. So that is how easy I can put it. Yeah, so if you're a student considering this opportunity, is a very good place to be, very satisfying, giving applied research, and communities are using it to improve their lives, very satisfying. So if you're interested in that, you can consider that as your route. China Rock and others are here. You can talk to them about it. They can give you a very good guidance on that. Yeah, so demographic of Arizona farming. When we look at these graphs here, why is there the need for small-scale farming activities here? Yeah, so we can see that in Arizona here from 1997 to 2017, using the USDA data, census data, you can see that the number of farms in Arizona is increasing rapidly. But when we look at the average farm size in Arizona, it's drastically reducing. That means that there is a need. The big farms are probably getting segregated into smaller pieces, and we are having also competition from other uses of land as well, making farms sizes reducing drastically with time. Yeah, so that means that we have to give a little bit more attention to small-scale growers because going into the future, that's probably what we're going to be faced with because our farm sizes are probably going to be very small, that we don't have big farms anymore. We never know. Looking at this trend, if you continue that way, that is probably what is going to happen. Yeah, so in Arizona specifically, the growing challenges are mostly soil health and water issues. And when you look at this map here, you can see that the darker color indicates like high organic matter and carbon content in those states. And you can see that Arizona falls within one of the areas where our soil organic matter, which is a very good indicator driver for soil health, is very limited. Also, this picture, I took it when I was flying in sometime, and you can see that water is basically a very scarce issue, and farmers are finding alternative ways, sustainable ways of using their water. And for this year, going to next year, it's even going to be worse because of the Colorado River level shortages. Yeah, so what this means is that farmers have to use innovative and sustainable ways of growing their crops. And in most cases, the small-scale farmers are more inclined to using these sustainable and regenerative practices than in most big farms. So I'll be running through some of the projects and you have a look at what is going on here. Okay, so when we talk about circular agriculture, what it is. So in the right-hand side, left-hand side, we see what the linear agricultural economy looks like. The raw material inputs are brought in, intensive field cultivation, production, harvest, and use the product, and then we have waste in the system that is not being utilized, also becoming an environmental problem. But when we look at what a circular agriculture looks like, you have a sustainable inputs coming in, sustainable production, invest sustainable harvest and reuse, and then recycling the material back into the production. So we don't have waste material generated. Yeah. So for our system here, the byproduct that we have, waste that we have in the field, if we can reutilize them, that would be a good source of carbon to our soil to enrich our soil health. And also the water can also be recycled to reduce, to increase the sustainable use of our water. And regenerative agricultural practices is basically in a similar trend, using alternative best practice management for using cover crops, using silvopasture system, manure to enhance the soil health profile, and also to some also include like animal health and best pay and social interventions for workers as well. Yeah, so regenerative agriculture is like a very broad concept that they have different views of it. Different institutions have different views of it, but in general terms, you can talk about rehabilitating the soil, resuscitating the soil using practices that will rejuvenate and regenerate the topsoil, increase the biodiversity of the soil, improve the water cycle, enhance the ecosystem services, and also supports biosequestration. Increasing resilience to climate change and adaptations is also one of the concepts around regenerative agricultural practices and soil health as well. Yeah, so in this picture here, I actually took it from Rodell Institute, who are the pioneers of organic agriculture. And this one here, I took it one of my stakeholders, one of the farmers here, one of the new farms. They just started here, and this is actually also from the DK, University of Arizona, DK ranch. Yeah, so when I came, because it's a new program, I don't know what the farmers are looking for. I don't know what my stakeholders were. So the first thing that I did in December was I did a IRB, that's the Institutional Review Board approach. I went through the IRB to have a need assessment done, a comprehensive one, of course, to understand the needs of the farmers. So any applied research that I would do geared towards helping the small scale farmers in making data more useful and available for them for decision making and things like that. Because in this area here, most of the research that is done is in Yuma, Maricopa. When you come up here, not my research is done up here in terms of working with farmers and things like that. So basically, local data is non-existing for this small scale production. Yeah, so I have to put in more effort to be able to do that. I started doing the extension work, which increase the volume of work, but it's more fun to do it this way. Yeah, so this is when I came, the first thing that I started in December. I was on the need assessment, then the coronavirus came and hit, so COVID-19, no programs. So the only intervention that I could do was to have an online program, which I call the Small Scale Farmers Colloquium, just to pull farmers together in these communities to give like virtual educational programs. And it's more centered around farmers. We're invited to give talks. Other faculty members were invited to give talks, other stakeholders as well. Yeah, so this was the pool of, this is the pool of stakeholders that I've been using this year to did the program. And this is how the attendance and the topics looks like. Because of time, I'll not spend so much time on this. Yeah, so I did to see, in essential, what we do is that we want to understand whether what we are doing is having an impact on the stakeholders or not. So for the colloquium in 2020 and 2021, I did an assessment to understand whether the farmers were gaining some knowledge from participating in this event or not. And we can see a clear evidence of knowledge gain. And then we also measured whether they intend to use the knowledge they gained from this event. Yes, they also, majority intend to use the knowledge gained in this event. And also Field Day was also organized this year for regenerative agricultural practices. And the turnout was great. 65 farmers turned out at the program. And it was much fun. They wanted more of activities in the outside field than indoor virtual programs. And hopefully with time, we'll be able to offer more of those programs. Yes, beginner farmers apprenticeship program, because most of the farmers are new, they want like one-on-one practice. And I did not have a facility to do that. So the only way I could do it is to have an apprenticeship program where those who are interested in learning will be paired with already existing farmers to learn from them. And whilst they learn from them, I also give them an online theory component of everything that they need to know, including food safety topics as well. Yeah, so in terms of research, it's around cover crops to rejuvenate the soil, because most people wanting to start a new farm, the land is so bare that they have to really rejuvenate the field before they can do anything. And cover crops are one of the options that they can use to increase the microbial activities, the carbon in the soil, and all these other indicators of soil health that we can think about. And so satisfying, you pull out this leguminous plant and you see these nodulations and you go like, wow, look at this cluster right there, which is so fun to be. So working in the field is very much fun. Yeah, so this is one of the applied programs that I'm working with the farmers. And it's good because most of the farmers are doing manual application direct. And one way is that to reduce food safety issues, if they apply the manure and put in a cover crop, to be able to break down the manure before they put in the main crop. In that case, we have a potential of reducing food safety issues in terms of like transmitting pathogens into the crops. Yeah, so this is one of the strategies that I'm giving the farmers, that to be able to use the either compost it or apply and then put in a cover crop, break down before they put in the main crop. Another issue is that we are having a very increasing trend of grape production in the area. So what happened is that they have a lot of byproducts, which is called the grape pomace. And what they normally do is that they don't utilize it, they throw it away. So when I came, I did a basic analysis, and I realized that it's a good material to use as a soil amendment. It's very low in pH, and our soils are very high in pH, so it can be used to minimize the pH at least within a time frame. And so I started encouraging the farmers to use it. This farmer used it, and you can see in this field here that on the left-hand side, they normally would just do fertigation, putting in their solutions through the irrigation system to fertigate the field. And the B, the farmer decided to spread, instead of throwing the grape pomace away, he decided to spread it in the field. So you can see when you look close onto the ground, you can see a layer of grape pomace in there. And just look at the biomass, you can see a very great difference in terms of the biomass and also in terms of the grape yield. You can see a very great difference in the yield as well. Look at the clusters here with addition of grape pomace and that. But when we look closer, we see the fertility increase in terms of nutrient uptake, and we see in terms of yield as well, but the sugar content was, there was no difference there. And the mechanism is, like I said, is very acidic. So I did a greenhouse trial to see how it affects the soil pH. And you can see in this graph that with increasing application of the grape pomace, the soil pH continuously reduced. But when you look at in the field content, you don't see any difference. That's why I said earlier on is that the pomace is made up of organic acids that act instantly on the pH, but it may not be a long-lasting effect, just like we have even for the sulfuric acid applications and things like that. And I also looked at how, because this is an organic acid-induced pH, with putting in organic acid in the soil will probably induce microbial activities as well. So I did a phospholipid fatty acid analysis to look at the organic microbial activities. And we can see that, yes, the addition of grape pomace intensified, enhanced both total bacteria, fungus, and then unidentified microbial activities in the soil. So in short, the mechanisms that are used within this grape pomace to enhance this potential growth in plant and yield is reducing pH, increasing microbial activities and biomass, and then also helping to increase nutrient uptake in the plant. But the issue is that using this material direct may have a foodborne food safety issue, because just as much as the material can increase any microbial activities, microbial pathogens could also be enhanced as well. Yeah, so we have to find ways of helping the farmers to be able to integrate a better approach, best management approach, to be able to reduce that potential. And what we have done is to use composting to assess, to see how composting can potentially help reduce that. And this is the composting we did. I did just for grape pomace, and then addition of poultry manure, and then poultry manure and zeolite as well, just to see how the addition of other materials could influence these activities. And as we can see, yes, we still have the total coliform for just the grape pomace higher in this composting material, but some way, somehow, addition of poultry manure and then a zeolite kind of reduce that potential a bit. And then we also composted in aerobic and anaerobic conditions. Under the aerobic conditions, we can see that the potential coliform is kind of higher, but under anaerobic, where everything was sealed airtight without any external influence, you could see that that was much better in terms of potential pathogens. Then the bacterial activities was also measured, a little bit influence there, yeah, but not so much, but significant differences were observed as well when we added the poultry manure. Yeah, so in simple terms, yeah, composting this material could be a better way to reduce the potentials that may exist in terms of pathogens in this and the use of this material as soil amendment that could transfer bacteria into pathogens into the food chain. Yeah, so we couldn't do so much because I used my personal funds to do that, program funds to do that. Yeah, so I used this basic data that I showed earlier to submit a grant to USDA, and we got good funding for it for the next 3 years to be able to assess the sterilized components and also the compost components to see how they induce soil health, also plant health, and we'll be able to compare the economics as well to see which one is more economical to use. And we are partnering with a company in Canada, Microbiome Insight, that will help us with the shotgun metagenomic analysis in the rhizosphere soil for us to be able to see how this material enhance the soil health as well. Yeah, so manure, as I said, is a potential material that the farmers use to enhance their regenerative and soil health activities, recycle it back into the field without disposing it. Yeah, so we can start, it's a very good material to use, but it has to be handled well using the food safety manual, reducing much contact to the vegetables as much as possible, and also allowing much time, the 90, 120 days, depending on what kind of crop it is, are some of the things that I've collaborated with Natalie, sharing some of the programs that she's teaching on the food safety to the growers so that they can participate in it. They are part of the exempted group, so they have to be just encouraged to participate to gain knowledge. We don't, they are not within the set of farmers that have to take the training, but they are encouraged to voluntarily take these programs to enhance their knowledge on that as well. Yeah, so another program that I've been working on with one of the farmers is this farmer has a ditch water, and instead of using the ditch water direct, he decided to have a fish pond. So having a fish pond and watering some part of his vineyard with a fish pond water and another part with a ditch water. Yeah, so when I came in from the soil science, soil health perspective, I wanted to know whether these two different sources of water have some impact on the soil health and the yield of his crop as well. Yeah, so this year I've been busy with him on that. Yeah, so basically this is how his farm is set up. So he has the water from the Clear Creek, he gets it through the ditch. He either use the ditch direct in the field or pump. He's not using a pump. He's actually a graduate from U of A who did engineering. So he's using just gravity flow. He engineered in such a way that he doesn't have to use any pump to push the water into the field. Yeah, so the water is pushed into the fish pond for about 3-5 weeks, and then he uses it on other parts of the vineyard as well. Now the vineyard is harvested, he processes it, he gets his wine out of it, the grape pomace, he brings it into his compost pile, compost it, and bring it back into the field. He kind of add external input, which is poultry manure from what's his name? Hickman Farms. He gets the poultry manure from Hickman Farms that he used to kind of induce add to the compost pile. Yeah, so that's the only external input that he brings in. He has geese in there. The geese kind of control weeds and also pests as well, which is awesome. Yeah, so I measured to see whether there are some differences in terms of the yield of these different watering with just fish pond and then the ditch water. And you can see the difference right here in terms of the yield. You can also see a difference in terms of nitrogen in the soil and phosphorus. This is interesting here. This field here control is the area of his farm where no watering is applied and no compost is applied, just the rainwater. And this farm has been in existence for more than 20 years. He's been doing this for more than 20 years. Yeah, so you can see that out of the control, we have more nitrate availability, of course, because nitrate is very mobile. When it leaches down into the soil, there's no plant root, deep plant root there to pick them up. So that's probably why we have a lot of nitrate availability in the control. But when we look at this red box here, we can see that the pond water is doing well in terms of the organic nitrogen and also the ammonium component of the nitrogen. And when we look at the phosphorus, we see a similar thing that the fish pond section is doing better in terms of inorganic phosphorus compared to the, both at different depths, both the 20 centimeters and 10 centimeters depth. You can see that the pond water is doing much better. Yeah, so in summary with this field, we can see that using the fish pond water is more sustainable. Instead of using it, the ditch water direct, of course, you still get a benefit of having fish with the same water. The water is enhanced in terms of nutritional component. Use it to fertilize your field, and then you get more return out of it. Of course, there is an initial investment that needs to be put in and also taking a little bit more space. But in terms of long-term benefits, it may be a very good alternative. Of course, there is also a red flag in terms of using this fish pond water. The good thing here is that the grapes are harvested on the plant, not on the floor. They don't allow it to drop before they harvest it. So this is good in terms of food safety. There's no contact with the water and then the final harvest, which may be a kind of good thing in some way. But if you're using this kind of practices in vegetables, that may not be more research needs to be done to be sure that this is not a source of contamination of pathogens and things like that. Yeah, another work that I've done so far is working, one of the vineyards, they're also using recycled water in their field. And the field, they have different, very good field for research. They have 3 different kind of soils based on the soil compositions. So you can see here, this is different from that, this is different from that. So we have a 20% clay here in this section, and the middle part here has 30% clay, and this my deeper one has about 60% clay. Yeah, so they're using recycled water from cottonwood, and all they do is to just produce, they don't really take care to measure whether it's affecting their soil and things like that. Yeah, so this year I went in to pick some basic data. Of course, heavy metals may also be an issue that need to be looked at, but you can see that yes, it's a potential source of water for agriculture. So the R is within the plant, the rows, and BR is between rows. Yeah, so the between, mostly the water is applied right here at the R within the plant rows and not between. So I took samples from within and between the plant rows to see if there are some differences in terms of where the water is applied direct and also where the water is not, recycled water is not applied. And you can see that it's kind of like a potential source of some nutrients for the plant. But of course, there's also a concern in terms of salt concentrations in the soil. And when we look at possible heavy metals, that could possibly also be a similar thing. I couldn't measure the heavy metals. That would be something that I'll need to do and measure in the chute as well to see how the heavy metals accumulation is within this plant. Yes, so the sustainable way to handle water issue here is to combine technology with extension programs that will definitely enhance the knowledge available and accessibility of this information to the growers, and to also enhance availability of information as well. But without that, the use of water will never be, if we are not able to combine the extension programs with technology and research in a very broad spectrum, the use of water in Arizona and across the South can never be a sustainable way. There has to be an integration of these three components to be able to maximize how much water we use and how sustainable and safe we use those waters. Yes, so in summary, the small-scale farmers have a potential of providing local food, fresh food, to our communities. They also use practices like regenerative agriculture and circular practices that increase bio diversity within our systems and are more resilient to climate change as well. And also they kind of increase the rural community employment and empowerment. They also reduce greenhouse gas emissions from transportations, because if we have more empowered local small-scale farmers, that means that we are reducing how much food transportations events we are having within the state. And that will help us reduce how much greenhouse gases. And also, because they're also a small scale, they're able to use practices like agroforestry, mixed cropping, and practices that cannot be used within the context of larger acreage. Yeah, so if we are empowering our small-scale farmers at different levels, we may be able to have more sustainable and safe food for our communities as well. Yeah, so thank you very much once again. I'll leave it here, and if there are any questions, we can discuss.
Thank you, Isaac. Yeah, great presentation regarding research and activities moving towards sustainable agricultural practices, specifically in the small farms. Yeah, really, really important information. We do have one question in the chat by Norm Barnett. In your experience, are the Arizona vineyards the only user of the grape pomace, or is it also used for non-grape growing farms such as vegetable farms?
Yeah, that's a very good question. Yeah, so actually, they are not much farmers are using the product. They are not using it. They throw it away. In primarily speaking, I visited most of the vineyards. They just, one of them is closer to the Verde River, and they throw it right by the Verde River. So that means that in the case of heavy monsoon events, the residue is just being washed into the river. Yeah, so we are now trying to encourage them to use it, which is the purpose of this research. And the funding that we actually got from USDA and NIFA for the 3 years is under the organic agricultural product, and they did not allow us to do the work under non-organic field. So we are working with a farm in Gilbert, Agritopia farm, and we're going to be growing spinach and carrots, spinach, carrots, and then green beans with these materials to see how they will enhance the profitability, soil health activities and profitability as well. Yeah, so it's not within the vineyards that it can be used within the context of any farm. Especially looking at the acidic content of it, it's something that we want to see the results and push it for like wider use, not within only Arizona. I think actually California will benefit more from Arizona because they produce more grapes and things like that. Yeah, so we are more open to, we have a lot of educational events that we'll do, and it will be open to anyone that is willing to participate and utilize the knowledge in their operation. Yeah.
Thank you, Isaac. Please go ahead and post your questions for Dr. Mpanga in the chat. I have a couple of questions while we are waiting, Isaac. So, great research on grape pomace, and I know grape pomace, has antimicrobial activity. And I know you were talking about composting with grape pomace, and I did see somewhere in your slides a terminology solarized grape pomace. So, have you tried using sunlight to dry it or decontaminate it, or if you can give a little bit more information on solarization?
Yeah, so the solarization that we're doing here, because we have like very high temperatures here, we just use the natural sun to dry it enough to make sure that it's well dried before we use it. And also we're going to compost as well. The idea is that we want to have a low-tech approach to using this material, so it doesn't have to involve like, that's my approach to working with farmers. As low-tech as possible, you can have something working for the farmers. It's more going to be adapted and used by the farmers than having something with complexity that the farmers have to invest a lot more to get it. That will reduce the use of the innovation. Yeah, so as low tech as possible, we're going for now. And then we are studying, Judy Brown is helping us as well, and Joey Blankenship Job is at the environmental department. He is also helping with his lab to do some nutrient analysis and things like that. So Brown will also be looking at the virus aspect of things, whether it's more reducing virus load or it's enhancing virus load in the field and things like that. And Ross Tronstead is having a graduate student as well. They'll be looking at the economics of things, see which one is more economical to use, things like that, yeah.
Mm-hmm. Yeah, oh, that's great. And do you ever test your grape, when you do research, do you test your grape pomace to see if it has any pathogens after solarization or, in general?
Yeah, so that's something that we did not do to see the after solarization, whether there are some pathogens. Actually, the original material too, we did not test it to see if there's some pathogens in it. I did a literature review and some indicated that it's able to reduce, there is a paper that indicated it's able to reduce pathogen load in the field, just using it direct. But probably you could help with that in your lab to see if this material has the potential to reduce pathogen load within the soil, in the context of soil. Yeah, so if there's an opportunity to crisscross around this area, anyone is interested in crisscrossing with some ideas, yes, it's more open for collaboration and stuff like that, yeah. Okay. Very basic at this point. We're yet to have enough data for other stuff, yeah.
Okay, yeah, thank you. And then I have one general question. Let me see if somebody has anything in the chat. No, I don't see anything in the chat. So I know you work a lot with the small growers. How receptive are small farmers to this new concepts of circular and regenerative agriculture that you discussed earlier? I was wondering if your needs assessment brought about, any of the findings with small growers.
Yeah, so when you look at the need assessment, actually the need assessment that is driving anything that I do. And after every year of colloquium too, I kind of get feedback from the stakeholder to see the kind of presentations or people we should be inviting to the events and things like that. And they are like, we need local data. We like just inviting somebody from somewhere to tell us what they have done there. We want something local. We want something that is done here, that is local data that we can say, okay, this is ours, Yeah, so I invite within the farmers themselves. Then that's why I work very closely with the farmers on what they're already doing. Yeah, so you can see most of the farmers, probably I should just go. The use of chemical is out of their radar. It's just a very few farmers that are using like chemicals in the operation. Is mostly using cover crops, and you can see it right here. It's mostly using cover crops and rejuvenating soil health activities that are more of interest to them. And then the integrated approach of managing pests and things like that. You can see that the use of chemicals for conventional system is, you see it right here, conventional agriculture, you see, most of them are not interested in that. Yeah, so yeah, that's of what is driving the farmers that I'm working with. Most of them are just maybe it may be less than 5% that are using conventional systems in their operations. Yeah.
Okay. Yeah, thank you. Does anybody have any questions before we wrap up? Okay, it looks like, yeah, I don't see any other questions. So thank you so much, Isaac. Yeah, great presentation and very useful information. We don't get to see what, small growers want and things like that. So this was very informative.